Hi class, in this recording we're going to focus on nerves and ganglia. Let's dive into it. So as we're looking at nerves, we first need to define what a nerve is. So as we're looking at these nerves, nerves tend to be or are defined as a cord-like organ that have nerve fibers. And when we say nerve fibers, I mean axons. And they're going to have some connective tissue wrapped around them. And as we look at nerves, we need to also emphasize that they are in the PNS, the peripheral nervous system only. These nerves allow for the central nervous system, so the spinal cord and brain, to communicate with the rest of the body. And as we look at spinal nerves in particular, spinal nerves, as their name implies, exit the spinal cord. They are going to have rootlets that are both on the anterior and posterior sides, and the rootlets merge together to form the spinal nerve itself, which we see down here at the bottom of the screen. Now, some nerves are going to only carry information one direction. Some nerves carry information two different directions. If it's a mixed nerve, it's going to contain afferent, so it's going to go towards the brain and spinal cord, and efferent, away from the brain and spinal cord. So mixed nerves contain both sensory and motor nerve fibers. The nerve fibers of the peripheral nervous system are going to be surrounded by Schwann cells. Once we get into the peripheral nervous system, the PNS, we no longer have oligodendrocytes myelinating the cells. Myelinating the axons. We now have Schwann cells myelinating the axons. And on the surface of the most superficial layer of the Schwann cell is referred to as the neurolemma, and wrapping around the axon, we have the myelin sheath, which is the main body of the Schwann cell. This is all review from chapter 12 material. Oh, wrong button. There we go. So, if you think back to our discussion of skeletal muscle gross anatomy, I use the bundle of bundles analogy. And that analogy works really well when talking about the anatomy of a nerve. It's a bundle of bundles. It's not quite as many bundles involved. As we're looking at, let's start from the outside in. I know I listed this from interior to superficial over here, but let's start superficial. So on the surface of a nerve, we have the epineurineum, which is analogous to the epimysium of a muscle. That epineurineum is going to contain the fascicles. And a fascicle is just a bundle of nerve fibers within the nerve, or a bundle of axons within the nerve. And wrapping around that fascicle, the nerve fascicle, I should say, we have a perineurineum. Perineurineums are analogous to the perimysiums of skeletal muscles. And these perineurineums have overlapping squamous cells that are going to form that membrane that helps to isolate the cell or the fascicle from the adjacent fascicles. Within a nerve, it's also worth emphasizing that we have blood vessels penetrating. If you've ever experienced what's it called, bleacher butt, or maybe you wake up in the middle of the night and your hand has gone completely numb because you're sleeping at an awkward angle, it's primarily because these blood vessels have been pinched off, and when the blood vessels are pinched off, we have nutrient play, or we have not enough nutrients getting to the nerve, and we can no longer transmit action potentials across these areas, or these regions, I should say, of a nerve, and then we lose sensation to that area. Let me clear the screen here. And then wrapping around the individual nerve fibers, we have endoneurineums. And that endoneurineum is going to be an electrically insulating layer that wraps around nerve fibers. So the endoneurineum in this particular figure is shown as blue. So I'm going to shift to blue here for us. So this blue membrane wrapping around myelinated and unmyelinated axons alike is going to be the endoneurineum. And this endoneurineum serves to electrically insulate one nerve fiber, one axon, from the adjacent axon. If you think of axons as copper wires in an electrical system, you don't want naked copper wires touching each other. That's a way to short circuit the system. And we don't want to short circuit our nervous system, so we insulate one axon from an adjacent axon, or one nerve fiber from an adjacent nerve fiber, using the endoneurineum. Hold on a second here. I want to make sure I didn't go too far. Okay, good, good. All right, let's get back to it. So, as we're looking at our nerve fibers, we have sensory and afferent nerve fibers. And these nerve fibers or nerves will carry information to and from the central nervous system. Afferent nerve fibers go towards the central nervous system, and they are going to enter through the posterior of the spinal cord. So they're going to primarily enter through the posterior rootlets. And then we are going to have motor or efferent nerve signals exiting through the anterior of the nerve rootlets. And we're also going to have mixed nerves. Mixed nerves are going to contain both those sensory, carrying information to the spinal cord, and motor, carrying information away from the spinal cord, signals. And as we're looking at these sensory and motor nerve fibers, sometimes they can be described as somatic or visceral, or general versus special nerve fibers. So there's different ways to describe the sensory and motor nerve fibers. The big thing that I want to emphasize to you is that sensory nerve fibers enter through the posterior, motor nerve fibers exit through the anterior. There we go. So now, we've talked about nerves. A nerve is a bundle of axons within the central nervous system. Let's talk about a ganglion. A ganglion itself is a bundle or a grouping of neurosoma within the peripheral nervous system, or outside of the CNS. So by definition, the peripheral nervous system. And this ganglion will be enveloped in the endoneurinium of the nerve to help electrically insulate it. And as it's being enveloped by the endoneurinium, it's going to be protected. This is where we can have some pre-processing that occurs outside of the brain. So we have a bunch of neurosomas, or cell bodies of neurons, grouped together that can do some integration. Very, very weak integration. The posterior root ganglion is going to be very commonly associated with spinal nerves. Let me clear the screen here and I'll back up the slide so you can see it with some perspective. Previous. So right here we have the posterior root ganglion of that spinal nerve. So here we'll have sensory information coming in to the central nervous system, and there's a very small amount, very weak amount of pre-processing that occurs. Most of the integration and processing will occur in the gray matter of the central nervous system, either the gray matter of the spinal cord or the gray matter of the brain. Oh, I jumped the gun there. So that's all we have for this recording. If you have any questions, please feel free to post them on the class discussion board, shoot me an email, and as always, happy studies.